So today we're going to talk a little bit about tire sizing, inflations, and the various valve stem configurations you're going to come across. So I took this tire off of one of our vehicles here at the school. It's a Ford Mustang, and I want you to pay close attention to the designation on the side of the tire. So the M+S indicates that this tire is, for traction purposes, good for mud and snow. The P means it's a P metric designation, and 225 is the millimeters of the section width. So the section width is what's right here between my hand, and it's slightly bigger than the tread pattern. It's actually, if you do straight lines up the sidewall, that's the section width. And then the next number is a 55. 55 is what we refer to as the aspect ratio, and it's, looking at this tire, it's the height of the sidewall, but it's not expressed as 55 millimeters, it's 55% of 225 millimeters. And then we have a R meaning it's a radial construction, and now we switch to inches, and it's an R16. 16 is the diameter of the rim. So it's a combination of metric and standard and the percentage for the aspect ratio. On this particular tire, we talked a little bit about the sizing, and I'm noticing now that over here we have a 94T. That T is representative of the speed rating of the tire. So this tire, and there's a chart that equates to a maximum safe speed that this tire could be operated at. Because it's just a conventional car tire, T is a fairly low rating. Another thing worth mentioning on this tire is it has a tread wear number, a traction letter, and a temperature letter. So tread wear is 360, traction is A, temperature is B. So as far as the letter designations, A's are better than B's, double A's are better than single A's. Traction is rated not on the ability of the tire to catch traction and go, but actually on the stopping distance required, or the stopping distance at a certain speed. Temperature is how well it holds up at a certain temperature, and tread wear is representative of the type of mileage we can expect to get out of the tire, and that's based on a specific manufacturer's scale. So let's say their lowest tire is a 100, and it goes up from there. So good tread wear numbers usually are 500 and above. And another thing you may want to notice about this tire is it has some cracking along the edges of it, which is what we call dry rot, and that has to do with the age of the tire, and the rubber is actually starting to decompose. So it's interesting to know how old this tire is. And to find the age of a tire, I'm going to look on the front for what we refer to as the DOT number, or Department of Transportation. And if I don't see it on the front of the tire, I'll flip the tire around, I'll look on the back side, and it's very visible on the back side. So after the DOT number, there's usually a 4-digit number. In this case, it says 3102. That means this tire was manufactured on the 31st week of the year 2002. We're in the year 2020, so that makes this tire 18 years old. From a standpoint of laws and legalities, we don't have a standard for the age of a tire in the United States, but the recommended replacement age is 5 to 6 years. If this was on a commercial vehicle, it would be 6 years, and if it was in Europe, it's 5 years, and then it's mandatory replacement regardless of the amount of tread left on the vehicle. So the next thing I'm going to do is, if I was going to mount or dismount this tire, I am going to have to remove the valve cover. And I have two two ways of getting the pressure out of the tire. I can use a valve core removal tool, and I can do it that way, unscrew it. Or, because this is a rubber valve stem, I feel confident that I can safely remove the valve core. If it was a tire pressure monitor and it was one of these aluminum stems with a nut on it, I would be very leery of trying to remove the valve core, because over time this aluminum corrodes, and when I'm removing the valve core there's the risk of it cracking or damaging, requiring sensor replacement. So I have these fancy things called tire deflators, and I remove the Schrader valve cap and I thread this on there, and it will deflate the tire without me having to physically remove the valve core. One of the other types of tire valves I might encounter is this particular one, not to be confused with a tire pressure monitor. This is a high pressure tire valve, and this is for wheel tire assemblies requiring 80 psi or higher. But when we dismount a tire, we treat every tire as if it has a tire pressure monitor in it. So now that we've talked a little bit about the different types of valves, we're going to go ahead and inflate this tire, and I'm going to use a digital tire pressure inflator. It's very important that we get an accurate inflation pressure because of our tire pressure monitoring systems. A variation in pressure between tires of 4 to 7 psi can cause the light to come on. And it's important to keep in mind that for every 10 degrees of temperature, tire pressure is affected 1 psi. So as temperature increases 10 degrees, pressure goes up 1 degree or 1 psi. As temperature decreases 10 degrees, pressure goes down 1 psi. So that said, it's important to know what the actual inflation pressure is also. And I can find that information in the door placard of the vehicle. In this case, it calls out 35 psi. If I look on the tire right after the load number in pounds, it usually gives me the maximum inflation pressure for this tire at that maximum load. And in this case, it's 44 psi. But to keep this within the specifications for best vehicle, optimal vehicle handling, I'm going to go ahead and inflate this to 35 psi using the digital inflator. And if I go over my inflation pressure, all I do is pull this handle halfway and it will actually deflate for me. So once I reach the target pressure, I'm going to go ahead and I'm going to put a Schrader valve cap on there to keep dirt out of the valve. Incidentally, if you come across one of these caps that's green, it means that the customer has paid extra to have that tire inflated with nitrogen. And what's unique about nitrogen is the selling point is that it's more stable under temperature as far as PSI change. That's why race car drag racers and race car drivers insist on nitrogen in their tires. Also, the molecule is a little bigger than the traditional air molecule that's in a tire, so it's less likely to leak out. So the next thing I want to talk a little bit about is tread depth. And when I am doing undercar inspections or I am doing New York State inspections, I will use a tread depth gauge, and I basically take this little T configuration, I put it across 2 tread blocks, I push down on this center plunger, and I go ahead and I read the number that lines up. There's a number and then a line, and it lines up with the top of this tube, and that is expressed in inches. So it's 30 seconds of an inch. So typically a new tire might have somewhere around 30 seconds of an inch. If it's an older tire, right, I'm going to expect less than that. So I'm going to switch gears and I'm going to go to this tire over here. And this tire has some significant tread wear. And one of the things I want you to take note of is there is built into all of the tires that we're going to deal with, modern tires, there are these bars called tread wear indicators. And those bars are at the 2/32 of an inch, which is considered to be the legal limit. So when I take a measurement here, I'm slightly above that 2/32, maybe double that. So I'm thinking that this is going to measure somewhere around 4 to 5/32 of an inch of tread height.